All right, well, it's very good to be with you this morning, and I am going to talk about how astronomy reveals creation. I think it's helpful for Christians to know some of the basics about astronomy, because astronomy is one of those fields where secularists have tried to misuse science to persuade people that the Bible's not true. And I find that offensive both as a scientist and as a Christian, because science comes out of a Christian worldview and always confirms biblical creation when it's properly understood. So we're going to see how the secrets of the cosmos confirm what the Bible teaches in the field of astronomy. And there are 4 secrets of the cosmos we're going to look at this morning. We're going to see how the glory of God is revealed in creation. That's something the Bible teaches, that the heavens declare God's glory, and we will see that the Bible is absolutely right about that. The evidence makes sense in light of what Scripture teaches. We're going to see that the Bible is right when it speaks to the basics of astronomy, things you would learn in any freshman level astronomy class. The Bible does discuss some of those things, and when it does, it's right because it's the Word of God. Of course it's going to be right. We're going to see that the Bible is right about the age of the cosmos. The universe is exactly the age that the Bible teaches. And again, it doesn't give us an exact number, but we know it's not millions or billions of years old. It's thousands of years old, and we'll see that the evidence is consistent with that. And then finally, we'll see that the Bible is right about the uniqueness of the earth. The earth is not just another planet, as the secularists believe, but it is very special, at least in terms of God's plan of salvation. This is the planet where God came to redeem those creatures that He made in His own image. And that is a unique honor. So let's jump right in and see how the glory of God's revealed in creation. Psalm 19:1 says, "The heavens declare the glory of God, the skies proclaim the work of His hands." And that's that beautiful synonymous parallelism that you'll see in Hebrew poetry. And it indicates that the universe has something to say about God, about His glory and His majesty. And it really does. And there are a number of ways in which the universe declares God's glory. I'm only going to talk about 2 this morning. I'm going to talk about the size of the universe and the beauty of the universe. These are 2 things that demonstrate that the universe is not an accident. It is designed by a magnificent creator and an all-powerful one. And the beauty of the universe is pretty easy to see. You don't have to be an astrophysicist to appreciate that. You can go outside on a clear night, get as far away from Denver as possible and look up, and it's just wonderful what you can see. And of course, I feel very privileged that we live in an age where we have pictures of, we can zoom in on these things. We have things like the Hubble Space Telescope and now the James Webb Space Telescope, and we can zoom in on these things, and the beauty is magnificent. Absolutely magnificent. The size of the universe, that is something that is hard to comprehend. And I dare say none of us really understand the size of the universe. I mean, we astronomers we have good methods by which we can measure the distances to these things, and it's just outrageous. And thanks to scientific notation, we can write these distances in a really small space, but can we really comprehend those distances? I don't think so. The best I can do is compare things to other things and give you a feel for how big the universe is and many of the objects that the Lord created within it. So we'll start with the moon. The moon is about the same size as the United States. That is, if you were to put the continental United States up at the same distance as the moon, it would cover the same area. You'd say, really? It's that big? Because I can cover it up with my finger held at arm's length. And that's because it's 240,000 miles away. That's how big the United States would look at that distance. And that's a distance that we can kind of get our mind around, 240,000 miles, because some of you, if you have a really good car, you might get 240,000 miles on it. So you could theoretically have driven to the moon, but probably not and back, right? So there you go. That gives us a little bit of a feel for that. So this is actually a mosaic image of the moon. It's taken lots of little pictures and stitched them together. And I love showing people the moon through a small telescope because it has a beauty to it. It's a desolate beauty, but it's there. And sometimes when people are looking at the moon, they'll say, can you see the flag that the astronauts plant? No, you can't see the flag. That's the size of the United States. You're not going to be able to see something as small as a flag. But the interesting thing is, we actually had a spacecraft orbiting the moon, the Lunar Reconnaissance Orbiter, and it takes high-resolution pictures of the surface. And so high resolution, we can actually see where the astronauts landed in the various Apollo missions. And so we're going to zoom in on Mare Tranquillitatis. This is where the first moon landing was, Apollo 11. It landed in this large dark region, which they call a Maria, which is Latin for seas, because they used to think they were seas. They're not. They're rock, basalt. But nonetheless, if we continue to zoom in on that, You can see the actual area where the astronauts landed, and you can see the lower section of the lunar module right there. That little, remember that spider-like looking structure that landed on the moon? And when they launched, they only launched the top portion of it to save fuel, so the bottom portion is still there, along with some instruments that they left. And you see that dark streak going to that crater and back? That's the footprints of the astronauts as they went over to that crater and back. So 50-year-old footprints, pretty neat. The moon is dusty. There's no maid service on the moon, so those footprints are going to be there for a long time. There's no weather on the moon, no air. So there you go. So yes, we really did land on the moon, and we have pictures of it now, which I think is pretty neat. So here's the moon in a first quarter phase when it's illuminated right down the side like that, and it's easiest to see the craters in that phase. That's the best phase to look at the moon through a telescope because you can see the craters. And it's interesting too, it doesn't show up so well on PowerPoint. When you're actually looking at it through the telescope, you can tell it's a sphere. The moon's not a flat disk, it's spherical. And your brain is able to figure that out by the way the light impacts on those craters. It's just the way the shadows are cast, your brain immediately figures out it's spherical. And I think that's amazing because that's actually a trigonometry problem that your brain somehow is able to solve very quickly. It's not only a testimony of the beauty of the moon, but the design of the human brain by our Creator. God has given you this amazing computer made out of meat in your skull. That's pretty neat. And it's amazing what it can do. Pretty sweet. So the moon, about the size of the United States, pretty big. But the Earth's bigger. Look at that. There's the moon compared to the Earth at their true scale. And we do have a big Earth. If you've ever driven through Kansas, you know the Earth is really big. Yeah. There you go. Some of you have done that. You know that. It's like, man, there's a lot of space available. And we do have a big planet. And I do feel very privileged, by the way, that we now have pictures of the Earth from space, and I enjoyed looking at those with Colonel Williams last night because that's just wonderful, something our ancestors only could imagine. And we do have a big planet, but it's small compared to other things in space, like Saturn, for example. Saturn is 9 times the size of the Earth, and that's just the diameter of it. It's 9 Earths across, and that's just the planet. The rings extend even further out. The rings are trillions of tiny little moonlets, pieces of rock and ice orbiting Saturn around the equator. And so you'd say, wow, okay, but we got a big planet. Saturn's big, 9 times the size of the Earth, and Saturn is big until you compare it to the sun. The sun's much bigger than that. The sun is 100 Earths across. Amazing. And again, you say, yeah, but I can cover it up with my finger. That's because it's 93 million miles away. And at that point, it's kind of hard to, because you don't have a car with 93 million miles on it. I can guarantee you that. Yeah. So you could not have driven to the sun. In fact, if you were to take a reasonable speed, like 60 miles an hour, something like that, and drive on a very long road, how long would it take to reach the sun? 160 years. So it's not something you can do in your lifetime. It just gives you a little feel for the distances involved in space. The sun is a star, or stars are suns, if you will. Those little tiny points of light you see in the night sky are the same type of object that the sun is. They're balls of hydrogen gas held together by their own gravity. So the sun's made of gas, hydrogen gas, and it's held together by its own gravity. Yes, gas has gravity. If you have enough of it, it'll hold itself in a sphere. And the sun is powered by nuclear fusion in the core, which is a very efficient power source. It's fusing hydrogen into helium that releases energy that eventually trickles to the surface and so on, and it keeps it stable. In fact, the sun releases more energy in 1 second than 1 billion major cities on Earth could use in an entire year. And it just gives you a little taste of the unlimited power of God. And the sun is one star. We think there's 100 billion stars in our galaxy, and that's one galaxy. So the sun is an above-average star in that most stars are smaller than the sun. Our nearest neighbors, like Proxima Centauri, is the next closest star, and then you got Wolf 359 and Gliese 674. These are smaller than the sun. Most stars are, but there are stars that are bigger than the sun, like Mintaka, which is one of the stars of Orion's belt. That you see, those 3 stars you see in the winter sky. You've got Alnitak, Alnilam, Mintaka is the one on the right. It's a blue supergiant, quite a bit bigger than the sun and much, much brighter. But there are stars bigger than Mintaka, like Canopus. Yeah, amazing. And remember, the sun's 100 Earths across, and this is many, many suns across. It's enormous. You got stars even bigger than Canopus, like Antares. That's that bright red star you see kind of in the south this time of year after sunset. That's Antares. Really amazing. And Antares is so big that if you were to put it where the sun is, we would be inside it. It would completely engulf the orbits of the inner planets. That gives you a feel for how big some of these objects are that the Lord made in space. Now, our solar system, though, is even bigger. Our solar system could be contained in a box that is 6 billion miles on the side. That's at least all the planets. There's other stuff orbiting the sun, some of it further out. But all the planets could be contained in a box 6 billion miles on the side. And the next largest object is much bigger than that, because even if we go 10 times bigger than the solar system, there's not much at that scale. Now we're 100 times bigger than the solar system, 600 billion miles. And at that point, you start getting the next the next object out there, which would be a nebula. A nebula is a cloud of hydrogen gas, and there's different types of nebulae. And if there's stars nearby, they'll heat up that gas and make it glow, and you get these beautiful colors. The smallest type of nebula, which is the one we're looking at here, is called a planetary nebula. It has nothing to do with planets, that's just a name. It's a planetary nebula because it's round and looks like an out-of-focus planet. But with a planetary nebula, there's a star in the middle, in the exact middle, that made that nebula. The star is ejecting gas out, and it's kind of a gentle process. So this is the Jewel Bug Nebula, and there you go. So that's what it's dynamic. It's expanding a little bit, century by century, it expands. And this is one of the smallest I could find. Another one that's a bit bigger is called the Ring Nebula. There it is. And I like this one. This has a special place in my heart because it's one of the first I learned how to find when you get a telescope and you start exploring the heavens. There is one spot, because most of the places you point a telescope, you see stars and stars and stars and stars, and it's beautiful, but it's just stars. There is one place where you will see a glowing smoke ring. It is so strange, because you're like, whoa, what is that doing there? And it's neat to see, and you're sort of expecting it to, because you've seen smoke rings on Earth, and they expand out, and this is expanding. It's just huge, and so it takes centuries to notice any expansion there. The star that made it is dead center, and that little star has collapsed in on itself and become a white dwarf. So we think that happens sometimes. And the neat thing about the Ring Nebula, it's about 1 light year across. People hear that term light year and they think, oh, that's time. It's not. It's a distance. It's a distance of about 5.88 trillion miles, about 6 trillion miles. And so that's a nice little indicator of, oh, that's a light year. A light year is a distance. And so when they say, the universe is billions of light years in diameter, that's true. That doesn't mean it's billions of years old. That's a separate issue. So here's another planetary nebula. Some of them have this 2-lobed structure because the star has an accretion disk around it. And we think that channels the gas out the north and south pole of the star. So really pretty, as you have here with the Ant Head Nebula. An even larger one is a different type of nebula. This is a diffuse nebula. This is not produced by a star. It's probably part of the original creation that God made. He made these beautiful nebulae and stretched them out. This is called the Horsehead Nebula, and you can see why. And so it's actually 2 nebulae. There's a bright nebula in the background and then a dark nebula in front of it that causes that horsehead shape. And if we zoom out, you can see the entire thing. This one's hard to see in a small telescope because it's red. And at night, you're using primarily the rods of your eyes, which are not color sensitive, and they can't see red very well. So this is tough to see. I have seen it, but it takes a pretty decent telescope to see it. It's easy to photograph, however, because cameras can pick up red really well. So there you go. And it's about 22 light years across. So if you're thinking, well, I want that in miles, all you got to do is multiply by 6 trillion, and that'll get you the miles. So there you go. There are structures even larger than this, like globular star clusters. I love these things. These are part of our galaxy. They kind of orbit around its center. And what it is it's a collection of about 100,000 stars, and they always have a kind of a spherical shape where there's more stars near the core, and then they get thinner and thinner as you go out. They are stunning. And I'm sorry, but the PowerPoint just doesn't do it justice. When you see it in the telescope, it is magic. There is nothing like it. And it reminds me of that passage that says that God calls them all by their names. God has a name and therefore a purpose for each one of those stars. We're not even sure how many are there. We think it's about 100,000, but that's an estimate. That's amazing. And all these things that we've looked at, the planets, moon, stars, clusters, nebulae, are part of a much, much larger structure called a galaxy. So that's a galaxy right there. That's a collection of 100 billion stars and nebulae and gas and dust and so on. So many stars, it's hard to see any particular one. And you say, well, I see a few stars. Those are stars in our galaxy. We have to look through our galaxy to see another one. Now, we think our galaxy looks something like that. It's a spiral galaxy, but we don't have a picture of our galaxy from the outside because we're in it, right? And we don't have a selfie stick long enough to get it out there. So there you go. But we think it looks something like that. So that's a galaxy. And we now know that there are other galaxies and that there are, in fact, billions of them, hundreds of billions of galaxies in our universe. Some galaxies come in clusters. This is called Stephan's quintet. And yes, you can see this in a small telescope. And no, it doesn't look that good in a small telescope. It looks like 5 little fuzzy things, but you can see it. I have. And it's actually, there's 4 galaxies that are actually part of the cluster, and those are the reddish ones. And then there's one that's actually much closer. It's not part of the cluster. It's photobombing the cluster. So there you go. So that's Stephan's quintet. As we go out even deeper into space, we find galaxy upon galaxy upon galaxy. Those are not individual stars you're seeing there. Those are galaxies. Each one of those little specks is 100 billion stars. Some more, some less. Amazing. This is the Hubble Ultra Deep Field, and until recently, this was as far out as we could go. And this was a little surprising to secular astronomers because in the secular view, they say as you look out deep into space, effectively you're looking back in time. Why do they say that? Because they say the light takes billions of years to get from there to here. Now, I've written articles showing you that that's not necessarily the case. Einstein found that you can actually get the light here immediately, depending on how you define now. And I'm not going to go into the details of that. If you want to read about it, you can go on the website and look that up. But the point is, the secularists believe that as you look farther into space, you're looking back to an earlier time because the light took so long to get here. And therefore, you ought to eventually look back to a time when there were no galaxies. Because in their view, the universe is 13.8 billion years old. And so if you look far enough, you ought to look back to a time where there was nothing. And so it was surprising to look at this. We're looking at an amazing distance here, and there are still galaxies. And so they thought, well, we're not looking back far enough. So we need a bigger telescope. Enter the James Webb Space Telescope. That was one of the motivations for building the spacecraft. And don't get me wrong, I'm glad they did it. It's an amazing spacecraft. So thank you for your tax dollars for funding this spacecraft. I know you had no choice, but still. I am in awe of the scientists and engineers who designed and built this thing. It is an astonishing machine and works incredibly well. And long story short, it can look farther into space than Hubble can, by quite a bit. And so secularists said, well, they made some predictions about what this telescope would find as it looks out into the farthest regions of space. And I want to share with you the secular predictions based on the Big Bang. They predicted that there would be fewer galaxies as you look far into space because in their view, you're looking back in time. And there should be a time when there were very few galaxies, and beyond a distance corresponding to a redshift of 14, there ought to be none. The farther away galaxies are, the more redshifted they are. So when you talk about redshift, think distance. So 14 is a whopping big distance. And that was the distance at which they thought that you really shouldn't have galaxies because you're looking back to a time that's less than, I forget the number, 350 million years after the Big Bang. And it's supposed to take galaxies longer to form than that. Okay? So fewer and fewer galaxies taper off as you go out because you're going back in time, and then there shouldn't be any beyond a redshift of 14. And as you get close to that distance, the farthest galaxies ought to be babies, right? Because they just formed. It's supposed to take time for stars to collect and grow until galaxies are supposed to get bigger over time as they gain mass. And so the farthest galaxies should be very low mass, low brightness, clumpy and irregular because it's supposed to take time for them to form into these beautiful spirals. So that was their second prediction. And their third prediction was that these farthest galaxies would have no what we call heavy elements. Now in astronomy, pretty much everything's a heavy element except hydrogen, helium, maybe lithium. Those are the 3 lightest elements. And the reason secular astronomers believed that the farthest galaxies would not have these heavy elements is because according to the Big Bang is only supposed to make hydrogen, helium, a little bit of lithium. That's it. It can't make stuff like oxygen and carbon and nitrogen. I won't get into the details of why, but that's their story, and I'm accepting it for the sake of hypothesis. And so if the Big Bang can only make hydrogen, helium, and lithium, what should the first stars be made of? Hydrogen, helium, and lithium. Those are the only elements available. And then the idea is that the heaviest of those stars and their cores eventually produce the heavy elements, and when they explode, they release the heavy elements like oxygen and carbon into the universe. And I thought, well, those are interesting predictions, but they're based on the Big Bang. I don't believe the Big Bang. And so I thought, I'm going to make some predictions too. Yeah. And so these are predictions I made, and I made these back in 2022, back in January, before the James Webb Space Telescope had started collecting data. So we didn't have any results yet, and I said, here's what I expected to find. And I basically predicted the opposite of what the secularists did, okay? So I predicted there will be lots of galaxies at great distances, even beyond a redshift of 14, because I don't believe you're looking back in time. I believe we're seeing the universe as it is now. I have a model that explains this. It's called the ASC model, A-S-C, ASC model. You can read about that on biblicalscienceinstitute.com. Anyway, so I don't see any reason why God would stop making galaxies at a redshift of 14. I think they go all the way out. And I'm predicting those farthest galaxies will not be babies. I don't believe God made baby galaxies. Because when God made Adam and Eve, he made them as adults. Yeah, God made a mature universe. And I believe that the galaxies that he made were also mature. Now, galaxies come in a range of sizes, but my expectation would be that's true not only for here, it's true for there. So the same kind of range of sizes of galaxies. Fully formed, massive, well-structured, not low mass, clumpy, and irregular. And I predicted that the farthest galaxies will have heavy elements, things like carbon and oxygen, because I don't believe in the Big Bang, that the universe started with only hydrogen and helium. In fact, I know the universe started with oxygen already in it. How do I know that? Because in Genesis 1, in verse 2, the Holy Spirit was hovering over the surface of the waters. What's water? It's H2O. O is oxygen. Oxygen existed on day 1, according to the Bible. Stars are made on day 4. Did oxygen exist first, or did stars exist first? According to the Bible, oxygen existed first. And the secularists, stars existed first. So that's why I'm making that prediction. So you got it? The exact opposite of what they're predicting. And I was confident enough that they would be wrong, because I believe the Bible, that I also predicted how the secularists would respond when their predictions failed. Okay? This is a fun one. Because I predict the James Webb Space Telescope will verify my predictions and refute theirs, and I predicted the secularists will respond with statements like, Webb discovers that galaxies formed much earlier than previously thought. Because I predicted they're going to find massive galaxies much further than they were expecting. Rather than give up the Big Bang, which is their cherished cow, they're not going to give up that. Instead, they'll say, well, I guess galaxies must form a lot more quickly and therefore earlier than we previously thought. So that's my prediction, okay? And you can read about those on our website, biblicalscienceinstitute.com. And there's the date, January 21st, 2022, before James Webb had reported anything. Later that year, in July, we got the first results from the James Webb Space Telescope, where it's looking back to this incredible distance, which in their view is back in time. Did it see basically no galaxies, because we're looking back to a distance where there were no galaxies? What did it detect? That. Yeah. Oh yeah, it's magnificent. And God spoke those into existence. That's just amazing. So what you're seeing there is galaxies upon galaxies upon galaxies. And if you're wondering, yes, the redshifts are very high for some of those. So what are the results of the James Webb Space Telescope data? Did we find just very few galaxies and then they stop at redshift 14? No. Lots of galaxies at great distances, even beyond redshift 14. Some of the estimates are up to a redshift of 20, which is way beyond what the secularists were expecting. Are they baby galaxies? No. They're fully formed, massive galaxies. Some of them are as massive as nearby galaxies. That was not expected by the secular view, but we creationists thought it would happen. And they're well formed too. They're not clumpy and irregular, they're spiral galaxies. Some of them are barred spirals, which secularists believe takes multiple billions of years to form. But there they are, almost as if they were just spoken into existence. What about heavy elements? The farthest galaxies do have detectable heavy elements. The James Webb Space Telescope has a spectroscope on board. It can break down the light and tell you what the substance that made the light was. And we've detected things like oxygen and carbon in these galaxies. They do have heavy elements. Isn't that exciting? So in case you're keeping track, creation is 3, evolution is 0 for this one, okay? What about my prediction of how they would respond? Remember, I claimed that they would respond by saying, Webb discovers that galaxies formed much earlier than previously thought. How did they respond? Galaxies started forming much earlier than many astronomers previously thought. How about that? You can read about that. There it is, Yukon Today, August 9, 2022. There it is. Massive galaxies formed earlier in the universe than previously known. There it is, Nature News, July 27, 2022. Evidence is building that the first galaxies formed earlier than expected. Sky and Telescope, January 10, 2023. So there you go. And there's lots of others I could cite as well. So there you go. See, the neat thing is the Bible not only tells me about the universe, which is how I was able to make the first 3 predictions, it also tells me about human nature, which is how I was able to make that 4th prediction. Yeah, anyway. And all that's spoken into existence by God in one day. That's interesting. God spent, if you read the creation account, God took 5 of the 6 creation days and worked on the earth for those 5 of the 6. He took one day out, that first Wednesday, and made everything else. Amazing. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars each. It's summed up in this little phrase, He made the stars also. Isn't that neat? Bible's a lesson in perspective, and so is astronomy. It's pretty amazing. 2 words in Hebrew, et kochavim. So there you go. Well, we've seen that the universe does declare God's glory, but what about the basics of astronomy? Things you'd learn in any freshman level astronomy class, like the spherical nature of the earth? The Bible does touch on these things. Some people have said, well, the Bible's not an astronomy textbook, and that's true. Astronomy textbooks change when we learn that we got some things wrong and we have to update them. But you know, God never had to correct the Bible. He got it right the first time because He is all-knowing. And so when the Bible touches on the topic of astronomy, which it does, it's right. And you can take that to the bank. The interesting thing to me, though, is when many of these statements were first recorded in Scripture, the secularists of the day would not have agreed, and today we'd have to agree the Bible got it right. That's what I find interesting. The Bible has a track record of being right when the secular world disagrees. For example, the shape of the earth. The Bible describes the earth, Colonel Williams mentioned this last night, as being circular because in Job 26:10 it says that He, that is God, has inscribed a circle on the surface of the waters at the boundary of light and darkness. Now that boundary of light and darkness is where evening and morning are occurring, and we astronomers refer to this as the terminator. That's where light stops or terminates. Okay, and so that the terminator is the boundary between light and darkness, and the Bible says that God inscribes a circle on the face of the waters, because the earth's surface is mostly water, at the boundary between light and darkness. The Bible tells us the terminator of the earth is circular, which it is. It has to be because the earth is spherical. And that wouldn't work if it were a disk. It wouldn't work if it were any other shape. It has to be a sphere in order for the terminator to be a circle. And I think that's pretty neat, because Job was written, we think, around 2000 BC. It's the oldest book of the Bible. Moses hadn't written even Genesis yet. Interesting. Even though Genesis contains information about earlier times, Job was written earlier. So I think that's interesting, because the secularists of the time did not believe that. The secularists, Job, again, written around 2000 BC, at that time, most people thought the earth was flat and floated in water. Most of them believed that. It wasn't until around 500 BC that the Greeks were the first non-believers to figure out that the world is probably round in the sense of spherical rather than a disk. And Pythagoras believed that. We're not sure if he had good arguments or not. We just know he believed it. Aristotle is usually considered the first to prove that the world is round. And you can tell that because when the ships are coming ashore, you can see the top of the ship before you see the bottom of the ship due to the curvature of the water. And there's other ways too. He realized that the Greeks had figured out somewhat approximately how to calculate things like eclipses. They didn't have a perfect track record, but they could approximate it. And they knew that during a lunar eclipse, the earth is between the sun and the moon. The earth's casting its shadow on the moon. It always casts a circular shadow, and no matter what the orientation is, and that only works if the earth's spherical. But I think it's interesting, because if Job was written 2000 BC and says the world's round, as far as I can tell, only the believers in Yahweh believed that until about 500 BC, and then the others caught up. I think that's interesting. God hangs the earth upon nothing. As Colonel Williams said, no strings attached, right? And that's exactly what we see. We have pictures of it today, showing that the earth hangs upon nothing. Might have been hard to believe when it was written. Job 26:7, 2000 BC. The experts of the day taught that the earth was flat and floated in water. How can it hang on nothing? That doesn't make any sense. Well, it does. It does now. We have pictures of it. Expansion of the universe. The Bible teaches that God stretches out the heavens as a curtain, spreads them out like a tent to dwell in, indicating that the universe started small and it's bigger now, apparently. So if God's stretching out the heavens and the galaxies were originally like that, then now they're like that, right? Because God's stretching them out. And there's some questions as to the exact mathematical nature of that. I've actually published an article on that recently. But anyway, it wasn't until the 1920s that secular scientists realized that is in fact the case. But up until the 1600s, most astronomers believed that the universe was static and eternal. That was one of the most common beliefs, at least among non-Christians. But the Bible says God's stretching them out, getting bigger. It was only until the 1920s that Edwin Hubble and others, by measuring redshifts of galaxies, realized that the universe is expanding, that galaxies are moving away from us and from each other, and therefore the universe is effectively getting bigger. So that's called the Hubble law. I think it's interesting that the Bible records that fact thousands of years in advance. The passage in Isaiah we think is written around 700 BC, something like that. So this was written thousands of years before it was discovered by scientific means. And it's really neat because the only way you can discover that the galaxies are moving away from each other and from us is with modern instrumentation. You need telescopes and you need spectroscopes. Telescopes to gather the light from the galaxies and spectroscopes to break that light into a spectrum and measure their redshift. But telescopes weren't invented until 1608. Spectroscopes were 1700s. You'd need modern technology to do this. But somehow, the Hebrews knew about it. It's almost as if they had a little divine insight into that issue, which of course they did. Oh, and by the way, some people think, well, if the universe is expanding and you run the movie backwards, it was smaller in the past, right? Right? If you keep going, does that mean that the universe exploded into existence 13.8 billion years ago? No. Just because something's getting bigger doesn't mean it exploded into existence 13.8 billion years ago. Some of you are getting bigger. That doesn't mean you exploded into existence 13.8 billion years ago, okay? Just means you're bigger than you used to be. So there you go. We understand that. As people say, but doesn't this at least confirm the Big Bang? Because, you know, the Big Bang predicted this expansion, and there it is? No. The expansion was discovered first, and then the Big Bang was a naturalistic attempt to explain the expansion. The expansion was discovered in the 1920s. The Big Bang was invented in 1931. George Lemaitre, who invented the Big Bang, he already knew about the expansion of the universe. He just thought that if you pushed it back, you could get everything back to a point, which is not true. But anyway, conservation of mass energy. The Bible teaches that the amount of stuff in the universe is consistent. And that's because God has finished his work of creation. He's still working today, but he's not creating new things. He's not speaking new animals into existence and things like that. And we know that because the Bible says that God ended his work by the seventh day. So there you go. So no new material comes into existence, because either it would mean God's still creating, which cannot be because God has ended his work of creation, or it would mean something can pop into existence apart from God, which cannot be because all things were made by him during the creation week. So nothing new is going to come into existence, and nothing's going to cease to exist, because God upholds all things by the word of his power. Christ in particular, it's God the Son whose power is holding this universe together. So those two principles together we call conservation of mass or conservation of energy. Einstein tells us mass and energy really are the same thing, just measured in two different ways. So the amount of stuff in the universe is constant. And that's interesting because Genesis, we think, is around 1400s BC. These other passages are New Testament, so they're all first century. When was the conservation of mass and energy, when were these discovered by secular means? Not until much later. The Greeks did not believe that. The Greeks believed that new stuff could come into existence and stuff could cease to exist. They did. It wasn't until the 1700s that we got conservation of mass, and it wasn't until the 1800s that we discovered conservation of energy. James Joule, considered the co-discoverer of conservation of energy, he'd done experiments where he'd measured that the energy that goes into the system is what comes out of the system. How about that? And it's interesting, though, because he was a Bible believer. And he mentioned, something to the effect, well, it makes sense that energy is conserved because God's not creating anymore. So he used biblical information to guide his research. And that is a very smart thing to do, if you want to get the right answer anyway. Then Einstein discovers that mass and energy are kind of the same thing, measured in different ways. That's 1905. But the Bible had it right first. The Bible describes Abraham's descendants, giving us an analogy that they would be as the stars of the heavens and the sand which is on the seashore. That's a sort of an analogy for a humanly uncountable number. And the Bible says as much in Genesis 32:12, which is too great to be numbered, the implication numbered by us. Now, God does number the stars and calls them all by name, but we can't. Too many. And you'd say, yeah, that's pretty obvious. I mean, you go out on a clear night, you can see several thousand stars. We estimate somewhere between 3,000 and maybe 10,000, if you have superb vision, is the number of stars you can see in the night sky. That's a big number, but it's countable. You might think, well, that's not such a good analogy then. I mean, the sand of the sea, yeah, but the stars in heaven, there's a few thousand of them. In fact, there was a time during the Middle Ages when many astronomers thought there were exactly 1,022 stars. What? Why did they believe that? Because the Greek astronomer Ptolemy had cataloged 1,022 stars. And although he never claimed that his list was exhaustive, there was a philosophy that everything worth knowing had been discovered by the Greeks. Really. It's interesting how wrong philosophy can prevent you from seeing something that's true, because you can see more stars than 1,022. Anyway, the telescope then was invented in 1608, and then Galileo makes his own in 1610 and looks up at the Milky Way. Oh, that's not just a cloud. That's hundreds of billions of stars. We think there's at least 100 billion stars in our galaxy, and you cannot count to 100 billion in your lifetime. You can't do it. So the Bible was right. So have we learned the lesson of history? Whenever the experts of the day have disagreed with the Bible's always turned out to be right. Yes, there were experts that said, no, the Bible's wrong about the earth being round. We know it's flat. And the Bible's wrong about the earth hanging on nothing. We know it floats in water. And those experts are what we call wrong. The Bible was right every single time. Have we learned a lesson of history? I hope you have. Not everyone has. Because there are secular astronomers today that say, well, we'd have to grant, yeah, the world's round and the universe is expanding and conservation of energy, but the Bible's wrong about the age of the cosmos. Because we know the universe is 13.8 billion years old. Well, it's not. It's not. The Bible is right when it addresses the age of the universe and everything within it, because it's the Bible, because it's God's Word. God knows how old the universe is. He was there when he created it, and he tells us he made it in 6 days, and it's, as Dr. Snelling explained last night, yes, those are ordinary, approximately 24-hour days. They're Earth rotations. Each one's bound by evening and morning. We know that. There's no doubt about that. Human beings are made on day 6, and from adding up the genealogies, we find it's a few thousand years ago. Can't get an exact date, but it's a few thousand years ago. And you know what? The science is consistent with that. It really is. And I'm happy to talk about things like radiometric dating, and Dr. Snelling could speak to that more than I can even. But my point is, there is evidence that if you look at it, is consistent with the biblical timescale and not consistent with the secular timescale. But how do we use science to refute the secular view? And the way you do it is with what's called an internal critique. I have to explain this a little bit, because you can't actually prove the age of something scientifically. What you can do is accept the hypotheses, the assumptions of your opponent, and then show that they lead to an inconsistency. What you can do is you can disprove their position, okay? So how do we do this? Well, there are certain assumptions. Whenever secularists say, we think this system is this X number of millions of years old, they're making certain assumptions. They're making certain assumptions about rates, they're making certain assumptions about initial conditions, and so on. What are the main assumptions that secularists make when they estimate the age of something? There's two big ones. Naturalism. They assume that God did not speak it into existence, right? So they would assume if you found an adult human, that human grew from a baby. Now, from everyone you've met, I'm sure that's true, but there are two exceptions to that. When God made Adam and Eve, he did not make them as babies. right? He created Adam from the dust of the ground and Eve from his side. And they were adults. They were one-day-old adults. That bothers people. They were made, some people say they were made with appearance of age. No, because age doesn't have appearance, not literally. They were made mature, would be a better way to say it. But anyway, secularists reject that. They would say, no, the way that Adam and Eve or anything came into existence is the same way it happens today, naturalism. And then they would say also uniformitarianism, which is the belief that present rates and conditions are indicative of past rates and conditions. If something's not happening that way today, then it never happened that way, basically. Yeah, that's the assumption there. So all secular arguments assume these two things, to varying degrees anyway, okay? Now what I'm going to do is show that even if I assume these, there are many situations where they lead to a result that is much less than the 4.5 billion years for our solar system or the 13.8 billion years for the universe. Okay, so and I had to mention that because some people get confused. They say, well, you're assuming naturalism and uniformitarianism. Yeah, I don't actually believe those. I'm assuming them for the sake of argument to show that they lead to a contradiction. That's a very powerful way of refuting a worldview. So let me give you an example. The internal heat from Jupiter. Jupiter actually gives off twice as much energy as it receives from the sun. It's relatively warm, and it's emitting heat into space. So it gets 1 unit of energy from the sun, gives away 2. Right? Gets 1 unit, gives away 2. And it's been doing that for every second of every day since creation. And what that means is it's losing energy, right? You take in 1, you spend away 2. It's kind of like our federal government. And you can't do that forever because eventually you run out of energy, right? It's like, think of it like a potato that you've just taken out of the microwave. You can feel the heat coming off of it, can't you? That's radiative and convective transfer. You can feel the heat coming off because it's warmer than its surroundings, so it gives off heat. Come back 2 hours later, is it still warm? No, it's room temperature now. It's equilibrated with its environment. Jupiter's still it's still a hot potato, okay? Now it's much bigger than the potato you take out of your microwave, and so it can emit heat for a lot longer. It can emit heat for 6,000 years, and it's not a problem. But if it's billions of years old, it should have run out of internal heat a long time ago, but it's still there. The problem's even worse for Neptune. Neptune gives off about 2.6 to 2.7 times as much heat as it receives from the sun, and it's still relatively warm. Isn't that interesting? It's almost as if they're not billions of years old. They're a few thousand years old. Earth's magnetic field. Earth has a magnetic field that has been decaying since creation, and electric fields are caused by magnetic fields are caused by electrical current, so you got current in Earth's core looping around like that. Maybe you've made a magnet, you take a coil of wire, wrap it around many times, touch it to the ends to a battery, and you can pick up nails with it. It's kind of neat. That's how magnets work. So the Earth has this magnetic field. It acts like an invisible shield. It deflects harmful radiation, so it's a design feature. And that magnetic field has been decaying over time. And we know the half-life. We've been able to measure that for the last century and a half, approximately. And we'd expect it to be an exponential decay. So as you go back, it gets, it starts out decaying very quickly, and then the decay rate slows. But the uniformitarianist assumption is that the half-life is constant. And we think it was disturbed during the flood year, and that flipped back and forth, but that just makes it drain it a little faster. So anyway, if you run this equation backwards, 6,000 years, the Earth's magnetic field would have been 20 times stronger than it is today. Your compass would have worked really good at creation. But if you run it back 60,000 years, the magnetic field is so strong, it'd rip the iron right out of your blood. You don't want that. Atoms could not exist with a magnetic field that strong, stronger than that of a neutron star. So there you go. So it can't be millions of years old. You say, well, maybe the rate wasn't constant. Well, then you're denying uniformitarianism, you see. And that's the way the secularists do it. They say, well, it's not an exponential decay, it's been oscillating and so on, but then they're violating their own standard of uniformitarianism, which you can do, but then there's no reason to believe in the millions of years in the first place. It's not just Earth's magnetic field, some of the other planets. Jupiter has a whopping big magnetic field, very powerful. You can get aurora on Jupiter. That's what you see on the top there. It's been enhanced so you can see it, but that's aurora borealis on Jupiter. That's caused by its powerful magnetic field. It can't be billions of years old. The magnetic field would be dead by now. Uranus and Neptune have fairly strong magnetic fields. In fact, a friend of mine, Russ Humphreys, he's a biblical creationist like myself and a physicist, and he predicted the magnetic fields of these planets back in the early 80s, before they had been measured. And then Voyager 2 flew past Uranus in 1986 and found that Dr. Humphrey's prediction was right on. The secularists were way off. They thought the magnetic fields would be dead for these two planets, but they're not. In fact, you can see that's an aurora on Uranus. Yeah, pretty amazing. And likewise with Neptune. Voyager 2 flew past Neptune in 1989 and detected a magnetic field consistent with Russ Humphrey's prediction, not consistent with the secularists. Secularists have invented what they call a dynamo model to explain, well, the Earth's magnetic field somehow recharges itself, and so do the other planets. And it flips back and forth and so on. But that model requires that the magnetic field be well aligned with the rotation axis, and it's not for Uranus and Neptune. It's pretty close for the Earth. It's not for these two planets. It's way off. Did you know the moon is actually moving away from the Earth due to tidal forces? It's spiraling away. The rate is slow. The moon moves 1.5 inches farther from the Earth every year. So we're not going to lose the moon anytime soon. It's a slow rate. But that's caused because of tides. You know, the moon pulls on Earth's oceans, and that causes two tidal bulges. It's pulling the water away from the Earth there. And if you're wondering why you get a tidal bulge on the opposite side, well, it's pulling the Earth away from that ocean. So it kind of stretches out the Earth that way. And then the Earth is rotating, and the Earth rotates faster than the moon orbits. They both go in the same direction, but the Earth's rotating faster. And so the tidal bulges get ahead of the moon, and they pull forward on it. And when you pull forward on something in orbit, what happens? It moves out. It's a little counterintuitive, but if you've ever played with a gyroscope, you know when things are spinning, they don't always behave the way you'd expect. But when the astronauts, Colonel Williams will confirm that when the astronauts want to go into a higher orbit, they thrust forward, and that moves them out. Which means, in the past, the moon was closer to the Earth, right? And we can do the math here, and assuming the same half-life, we run the equation backwards, and you have to do the equation properly because as the moon gets closer to the Earth, the tidal bulges would be bigger and the rate would be faster. And so it actually speeds up. It's a 1/r⁶ relationship. The uniformitarian assumption is that it's always been a 1/r⁶ relationship. So you run it back in time, and you find that at 1.45 billion years in a hypothetical past, the Earth and moon would have been in the same place at the same time, which cannot be, right? And you'd say, well, 1.45 billion years ago, they can't be older than that. That's pretty old. Yeah, but the problem is in the secular view, the Earth and moon are supposed to be about 4.5 billion years old. You see, 1.45 is less than 4.5. For those of you that are Common Core educated, I just wanted to explain that. There you go. If there's a worse way to do math than Common Core, I haven't discovered it. Comets are made up of ice and dirt. They orbit in elliptical paths, going far away from the sun where the ice remains frozen, and then they swing in and they whiplash back out. And every time the comet comes close to the sun, some of that icy material is ablated away from the surface, and that makes the comet smaller. Every time you see a comet, it's losing mass. And by the way, you're going to get two nice ones here next month. Look in the west, in the evening sky, you'll see a couple of comets, maybe naked eye, so pretty neat. Anyway. But they don't last forever because they're losing mass. And we know the amount of material that's there. We know the rate at which it's being evaporated. We estimate a typical comet could last no more than about 100,000 years maximum before it completely runs out of ice. But the solar system's supposed to be 4.5 billion years old. So you see, comets are a problem for that. And the secularists have said, well, there must be a source of new comets, kind of a comet generator, which makes new ones, which they call the Oort cloud. If you've heard of the Oort cloud, that's an attempt to solve that problem. There's no observational evidence of an Oort cloud, but you'll find it in the textbooks. You won't find it in your telescope, but you will find it in the textbooks, because that's the only place it exists, as far as we can tell. The surface of Pluto, this was just a treasure. When we sent a spacecraft past Pluto, launched it in 2006, took 9 years to get there. In 2015, New Horizons flew past Pluto and discovered a very youthful surface. This was astonishing to the secularists, because they figured Pluto's out there. It's a small world. Pluto's only 2/3 the size of Earth's moon. It's small. That's one reason, if you're wondering, that's how it got demoted. Too small to be a planet. Sorry. Too small. Anyway, they discovered regions like Tombaugh Regio here where there are no craters, not one impact crater. Over 4.5 billion years, nothing hit it. And yet there's evidence of geological activity. I mean, they would say maybe stuff hit it, but it's been erased by geological tectonic activity. Okay, but that requires heat. And Pluto's only 2/3 the size of Earth's moon. It can't retain heat for 4.5 billion years. Either way, you got a problem. Unless you're a creationist, and then you have a feature. There are mountains on Pluto made of ice. Ice is as hard as rock at that distance, so it acts like, it's interesting, it's a different type of tectonic activity involving ice with water ice with a thin layer of methane ice on it. These mountains, I know you can't tell, but those are as tall as the Rocky Mountains. That's amazing. And that would not be expected for a planet that's theoretically been geologically dead for 4.5 billion years. Pluto's moon, Charon, likewise. Spiral galaxies can't last billions of years because they wrap themselves up. The inner portions rotate faster than the outer portions in terms of their angular speed. And I ran a simulation. This is based on the actual measured velocities of those stars in the Whirlpool Galaxy. And I wanted to see how long does it take for a galaxy to wrap itself up beyond recognition. Because the galaxies we do see are like this. And those are supposed to be 10 billion years old. But I strongly suspected that spiral structure wouldn't last 10 billion years or even 1 billion years. So I ran a simulation. Here's the result. The number at the bottom is the number of millions of years. And you can see by about 100 million years, it is very tightly wrapped. Look at that. And we don't see galaxies that look like that. By 300 million years, so we're just a few seconds away from that, it's like a phonograph record. And we do not see galaxies anywhere in the universe that look like that. Sometimes you'll run into secularists that say, if the universe is young, why does it look so old? And I'm like, I don't know what universe you're looking at, but this one doesn't look millions of years old. We do not see galaxies that look like that. This is called the spiral winding problem. I studied it in grad school. I call it the spiral winding feature. Blue stars can't last billions of years. That's universally acknowledged because they use up their fuel quickly, and yet we find them everywhere. The secular idea is, well, they've formed recently. But gas doesn't want to just collapse in on itself. Gas in space tends to expand. And so all secularists assume that star formation is happening today. We have yet to see it. We have yet to see it. Anyway, the evidence is really consistent with the biblical timescale. And again, I've given you upper limits. What I've done is I've temporarily assumed the secular assumptions and showed that they lead to an inconsistency. I'm not trying to give you the true age of the universe. I'm just pointing out that the secular view is wrong. It's internally inconsistent. And then finally, the uniqueness of the earth, and we'll have to speed up on this one. The Bible is right about the special nature of the earth. It's a planet that God formed to be inhabited. And that is something that is very special to earth. Isaiah 45:18, He is the God who formed the earth and made it. He established it. He did not create it a waste place, but formed it to be inhabited. This is the planet that God put life, and in particular, those life forms that are made in His own image. That's pretty special. And I'll grant the Bible doesn't say, and He didn't do that anywhere else, but that does seem to be the implication, is that earth uniquely is designed for life. The other worlds that God made, not designed for life. The moon, not designed for life, at least on its surface. One of the astronauts, Buzz Aldrin, who walked on the surface of the moon, referred to it as a magnificent desolation. I think that's a great description of the moon. It's not designed for life. The astronauts who went there had to take a little bit of earth with them. Oxygen from the earth, food and water from the earth to survive. And they didn't stay there very long because the moon it doesn't have a protective magnetic field like the earth does to deflect cosmic rays. So you can't live there for very long. Anyway, not designed for life. Earth's neighbors, beautiful planets. I'm glad the Lord made them. They're fun to look at in a telescope. And they're for signs, seasons, days, and years. They help us to know which year it is and so on. We have modern technology to do that now, but the ancients relied on these. But they're not designed for life. Mercury and Venus, way too hot. Surface temperature on Venus, over 900 degrees Fahrenheit. Enough to melt lead. Mars, too cold. And it has a toxic atmosphere of carbon dioxide, very, very thin. Earth, just right. It's like Goldilocks and the Three Bears, right? Yeah. And so that's why I don't expect to find life out in space, and I'm going to skip that section because I don't want to eat into Dr. Snelling's time, or he'll accuse me of going for millions of years. So there we go. I just want to sum it up by saying this. We live on a very beautiful planet that the Lord made, and the evidence is very consistent with biblical creation. And of all the things that we've looked at, this is a very special planet. One of the astronauts who walked on the moon, Jim Irwin, I'm paraphrasing him, but he said something to the effect that the amazing thing is not that man walked on the moon, but that God walked on the earth. This is the planet that God Himself visited and died your death. That's awesome. Died your death, died my death, so that we could be reunited with Him. That's awesome. That's something to think about. We serve an awesome God indeed. So the book that covers what I covered today, it's called Taking Back Astronomy. You'll find it out there. It covers all this stuff except the James Webb Space Telescope stuff, because that's brand new. That's very, very recent. And then we have Stargazer's Guide to the Night Sky, How to Better Enjoy the Night Sky from a Christian perspective. That's a fun resource. If you'd like to learn how to find some of these things in a small telescope, some of them you can see in binoculars if you know where to look. And that book's going to help you to do that. If you want to get a telescope, what kind you might want to get and how to use it and so on. That's just a fun resource. The Physics of Einstein, if you're wondering about light travel time and stuff, and is time travel possible, and what about black holes, all covered in that book. Written at a layman level, but I have in-depth boxes for students who want to go into more depth. You can either read those or skip them, either way. The Importance of Genesis, I think this is my latest book. It's why Genesis matters. And yes, Genesis really does mean what it says, and the Christian doctrines that we hold dear go back to Genesis. And if you want a little more in-depth on that, Understanding Genesis, where I refute some well-intentioned but mistaken Christians who believe in millions of years. So check that out as well. If you want a bulletproof argument for creation, this is it, the ultimate proof of creation. And you might think, well, didn't you just prove creation? No. I showed the evidence is consistent with it, but I haven't actually demonstrated it. If you want a demonstration, it's in that book. And it's a very powerful resource. I wish college students would read that before they go off to college, actually. You might have some different testimonies there. Keeping Faith in an Age of Reason answers over 400 alleged Bible contradictions. You've heard the critics say you can't believe the Bible because this verse contradicts that one. Yeah, well, it doesn't. I checked. And I wrote a book responding to those. So it's a nice one to have just on your shelf as an index book, because it answers over 400. So if somebody accuses the Bible of having a contradiction, the answer is probably in there. Discerning Truth, how to spot logical fallacies in arguments that evolutionists commit. That's a handy skill. Introduction to Logic, how to use your mind rightly and to the glory of God. That is a lost skill in our culture, right? We need to get back to logic. Our culture's been taught to emote rather than to reason. And this is going to show you that logic is actually rooted in the character of God. The reason we can be logical is because God is logical and we are made in His image. You'll have that back there on the table. We didn't bring everything here. We do have a teacher guide for that as well. You can get it on the website, but we didn't bring the teacher guide here. Fractals, Secret Code of Creation. I'm going to be talking about that this afternoon. God has built incredible beauty into an aspect of creation most people have never even thought about. It's really cool. For this conference only, we're taking all of our books and offering them at a 20% discount. And we're also going to throw in Danny Faulkner's book, Refuting a Flat Earth. And yes, you need to know how to refute that, because flat earthism, it's becoming almost a cult. And you need to be able to reason with these people before they go down that rabbit hole, because then you can't reason with them anymore. So anyway, get the best of our resources for 20% discount. That's today only. So do check that out. And we do have a free monthly newsletter. Make sure you sign up for that. It's an electronic newsletter, so make sure you put your email address or you'll get nothing, okay? Put your email address. It comes out once a month. We just want to bless you, and it'll kind of keep you informed on what we're doing at the Biblical Science Institute. So it is a free resource. Not too many things free in this world, just salvation and our newsletter. So check that out, and check us out as well.